Well, I think it's 4 o'clock, so we should probably get started. Hello, everybody, and welcome. My name is Jane Lawrence, and I'm a program manager on the Windows Device Connectivity team. For Windows 8, my focus is on USB compatibility and Windows hardware certification. Today, we're going to talk about how to build great USB 3 devices. I will start with an overview of USB 3 specification and the benefits that it offers for our customers. We will then spend some time looking at the hardware development model and look at the various stages and see what design options are available to you. I will provide some recommendations on how to enable the best Windows 8 and USB 3 experience for your devices. We will briefly talk about compatibility and Windows hardware certification and testing guidance that is available to you. At the end of the talk, I hope you're really excited about USB 3 and that you know what the next steps are to start integrating USB 3 in your device experience. Let's get started. USB 3 is here, and it's really fast. It's actually 10 times faster than USB 2. What does that mean for our customers? Well, that means that you can copy music and pictures in a blink of an eye. You can sync your devices pretty much instantaneously. So anything that has an SSD card in it, you can plug it in, click sync, and you're good to go. But the main benefit of USB 3 can be really seen when you're dealing with large files. Like if you're doing file transfers over 25 gigabytes, you can do that with USB 3 under 2 minutes. Because USB 3 completes transfers faster, it uses less power overall on the bus, while at the same time, it provides more power to the devices that are connected to USB 3. So in some cases, you don't even need to provide a wall charger for your USB 3 devices. You can just charge them by plugging them directly into your PCs. So no more of those Medusa two-headed cables, yes, necessary. Another part of USB 3 that's really exciting is that it's fully backwards compatible. And so all of the existing USB devices will work when you connect them to USB 3 ports on your PCs. Similarly, when your USB 3 devices get connected to older USB 2 PCs, they will work. And today, we actually have USB 3 support in Windows 8 in box. So we created a brand new USB 3 stack, and I'll talk a little bit more about that. Want to see how fast USB 3 is in Windows 8? I know many of you have seen the demo that Mike and Julio did during the keynote, and it was really exciting when he did the comparison between USB 2 and USB 3 file copy. Well, today we have something different for you in store. And I'd like to introduce Yang Yu, who's a fellow PM, and he's going to show you the demo.
Hi, everyone. I'm Yang, and Jane's and Christina have already talked about how fast USB 3 is gaining adoption in the devices space. And so millions of devices are being sold with the new USB 3 capabilities. And there's actually a lot of innovation happening with these devices. So today I'm going to show you a cutting-edge application of USB 3 with Windows 8. So what I've got here is actually a USB 3 add-in card. And as Christina and Jane have probably mentioned earlier, each USB port has about 5 gigabits per second of bandwidth available to it. So this particular add-in card is called a RocketU USB 3 controller. And what makes it special is that it actually has 4 USB ports with a dedicated ASMedia controller for each port. And then in addition, there's actually a PCIe by4 express bus connecting the card to your computer. What that means is there's 20 gigabits of bandwidth available to this card with 5 gigabits available for each USB port. And that's a lot of bandwidth. So there's a feature in Windows 8 called storage spaces that really allows you to take advantage of this bandwidth, especially for storage devices. Now, wouldn't it be cool if on Windows 8, wouldn't it be cool if when you plug in multiple devices, you can actually aggregate all of that bandwidth? So what I'm showing here is a desktop that I've got under the table. And there, as you can see, there's 4 USB 3 controllers, each one with a storage device connected to it. And so here in the disk management view, you can see that there's 4 unallocated drives. Storage spaces is a new virtualization feature that allows you to pull several storage devices together, whether that be on SATA or USB. So in this demo, I'm going to show you how you can aggregate a bandwidth from several USB devices. Now, PowerShell is one of the many ways you can manage your storage space. And so I've created one script, a simple script, that can create a new storage space. And so what this script is doing is it's taking all the unallocated devices that are connected to my computer and pulling them into a virtual pool. And so with another command, I can optimize this pool to create a virtual disk that's optimized for high performance. And so this script is going to create a virtual disk out of the pool and then assign a drive letter to it. So why don't I run a benchmark on this? This is the Crystal Disk Mark tool, which is a popular benchmarking tool. And what it's doing now is creating a 1 gigabyte file on the virtual disk. And while it's doing this, Storage Spaces is actually splitting the file into 4 parts and writing to all 4 disks simultaneously. Then it's going to read back the data and calculate the performance. That's 765 megabytes per second of throughput.
Wow, that's fast.
And this is with off-the-shelf components that I've just picked up from an electronics store for less than $600. And so it's very difficult to get this amount of performance, especially in a home usage environment. And so with this much bandwidth available, it really allows you to do cutting-edge applications such as editing HD uncompressed video files. So this is just some of the innovation that's happening with USB 3. And it's really important to get more USB 3 devices that take advantage of the bandwidth that's available. So Jane's going to really tell you guys how best to leverage the tools that we've made available in Windows 8 to build the best USB 3 devices.
Thank you, Yang. How fast would USB 2 do this?
It'd be stuck at about 30 or 40 megabytes a second. So if you're transferring a large file, you'll be waiting for a while.
I bet you're all wondering when this experience can come to every PC and every device out there. So let me show you some Instat projection data that we have. Oh, some technical adjustments necessary?
Right, just got to switch back to your presentation.
There we go. So Windows 7 USB 3 enabled PCs are already shipping today. And so looking at the Instat projections, by 2014, every PC... All right, we're good to go. And so looking at the Instat projections, by 2014, every PC that will ship will have USB 3 in it. And by 2015, we're expecting that there are going to be about 3 billion of USB 3 devices on the market. So in order to really take advantage of USB 3 performance that Yang demonstrated, you need both the device and the host to support USB 3. And so with the rapid adoption in the PC space and the growth we've been seeing, there's a great opportunity for devices to take and create this experience. One thing to keep in mind is that USB is the most reliable and robust bus today. And so we have had over a decade to perfect the USB 2 experience. Customers are used to just plugging in their devices, and they continue to work, so they don't need to mock around with them or to adjust them. they will have the same bar for USB 3 experience. So they will just expect their USB 3 devices to work. The specification for USB 3 is fully backwards compatible, which is goodness. However, the challenge becomes around the integrating between the software and the hardware together. So how do we work together to enable this just works experience for USB 3? We start with picking the right set of components. Then you design your firmware to really utilize USB 3 functionality and the performance features that it offers. You can use one of the inbox drivers that we have available for you to work with your device, or you can create a custom driver if you have some custom set of features that you want to light up in Windows. The last piece to all good engineering practices is testing. And there are a couple of certification programs available to you, and we'll talk about them in more details. At the end, based on the test results, you might have to go and tweak your firmware or have some driver updates to fix some of the issues. And you repeat this cycle until you accomplish a successful, reliable USB 3 development. So let's look at the first piece, the components. Most firmware is upgradable, and for drivers, you can easily implement changes and republish it. However, for hardware, once the silicon is baked, it's pretty much impossible to make changes to it unless you spin a new version of silicon, and that is costly and might set you back in terms of schedule and resources. And so it is incredibly important to pick the right set of components to integrate into your USB 3 device. That is going to be your foundation. When I think about USB 3 components, I think about USB Implementers Forum. This is the organization, along with a number of partners, that is behind all of the USB specifications out there, including USB 3. They also help ensure the devices that implement the specification do so correctly, and they offer many compliance programs and workshops and test events. At the end, after those components pass through the certification, that list gets published to other participants to review and use when picking their devices. So, as a device manufacturer, you might have a question. Should you build your own USB 3 component, or should you leverage one of the existing ones? Well, if you choose to build your own USB 3, it does give you more flexibility, and so you can bake more features into the silicon directly, so it makes your firmware and your driver a lot more simpler in the future. You might also want to sell your chips or license the IP to other vendors, so you can create additional market opportunities for your company. However, silicon development is very complex, and so it requires expertise, special resources, time. There's a cost associated with it, so it might not be a viable option for every company. The easier and faster option to market is to use one of the existing USB-IF certified components. And so with that, you do have some licensing costs to consider, and you also probably would not be able to customize it, and so you'd have to write a more complex firmware and driver to accommodate what you got from the other vendor. Another question you might have is whether you need to get your device fully USB-IF certified. So USB-IF today offers various device programs for certification of USB 3 hardware. You have an option to participate and get full IF certification, so you can display SuperSpeed USB logo. However, from a Microsoft standpoint, we don't require full USB-IF certification. Part of the reason for that is we understand that it could be costly, and so for devices in particular, you have an option to just run a part of the tests that USB offers, which is the interop and CV tests. All controllers are still required to get full USB-IF certification because they are integrated into the systems and they do have to work with various devices. So it is important to get the electrical and interoperability and other types of tests that USB-IF certification offers. So what did we just learn? We talked about USB-IF and we talked about the benefits that the participation provides. Like, for example, access to exclusive test events, workshops. You will have an opportunity to review specs prior to them being finalized and provide feedback so you can help develop the next standard. You also get to interact with other partners in the industry so you can exchange information and find out about new upcoming products. But the most important thing is you get access to the integrators list that has all the certified USB hardware available to you. So it makes your decision for what components to use much easier. And so I strongly recommend that you consider USB-IF certified components, as with that you can guarantee that a certain quality bar has been met on them. Now let's switch gears and look at the firmware side. Firmware development is also very complex. And so it is unique to different device types. I'm going to talk about two things that are common to most, which is the power management and also the representation of USB devices in Windows. With the recent shift to mobile devices, power consumption is becoming a gating factor for many consumers when they're choosing what PC to purchase. They want smaller form factors and a longer battery life. They want one device that they can carry around with them at all times that lasts them through many days without needing to charge it. Enterprises are considering power consumption as well and actually reevaluating their desktop purchases to find more power efficient and greener solutions. USB Selective Suspend is a feature that's been available since USB 2, and it allows you to suspend your devices and put them in the lowest power state while the PC is still active, but the device is not used. However, many devices nowadays are multifunction devices. And so for USB 3, Selective Suspend offers now an additional option called Function Suspend. And Function Suspend allows you to suspend a certain function of the device without the entire device needing to be idle. So for example, if you have a multifunction printer device at home, most likely it will have a printing component, it will have a scanner, and it will have a storage. It is very unlikely that the customer will be using all three at the same time. So what you could do is you could suspend the scanner and the storage pieces, while at the same time you can keep the printing piece active, listening for any incoming print jobs. Power management can also be done at a link layer. And link power management has been introduced after USB 2 specification has been ratified as an addition. And so for USB 3, it's been revised to provide more precision and more control, and now it supports 4 different states and uses less time to transfer from one state to another. And so it is required as part of the USB 3 specification. The Windows 8 USB 3 stack fully supports link power management on USB 3 hardware. So I encourage you to take advantage of the power savings by utilizing the lower links when implementing your devices. Now let's look at the Selective Suspend a little bit more. Many devices, such as fingerprint readers or other biometric devices, are only used intermittently. And so suspending such devices reduces the overall power consumption. And it actually allows for the controller to go into lower states and become idle. So it allows for the system to go to sleep. This is in particular important for devices that are connected to the controller at all times, like embedded devices that are within the plastic. And so for all the internally attached devices, we recommend that you implement selective suspend very aggressively. For Windows 8, we added support to two class drivers. Mass storage supports selective suspend now for both BOT, which is bulk-only transport, and UASP, which I'm going to touch on in a little bit. And then we also added it for NDIS and RNDIS. So now in Windows 8, all class drivers for internally connected devices support selective suspend. So you can easily suspend your devices. Let's summarize what we just learned about power management in USB 3. There are various options available to you. Selective suspend allows for you to suspend your device into the lowest power state. Function suspend in USB 3 actually addresses some of the previous limitations of selective suspend and allows you to suspend particular functions of the device without the entire device needing to be idle. With link power management, the device is in control. So if you know that the device will be idle, you can request to go into the lower link states right away. Now let's look at the device representation in Windows. For those of you that were around Windows 7, you are familiar with the concept of Container ID. Container ID allows for a multifunction device that has different functions in it to be represented as a single picture in Windows devices and printers view. A container ID is an identification string, which is supplied by Windows to Windows by the bus driver stack. And so this way, when a multifunction device is connected to it, it will appear as a single piece of plastic. So let's look at the example. Multifunction printer, it's my favorite. It's got the printer piece, it's got the storage, and the scanner. And so if you look at the device manager, you'll see that there are three specific different functions, 3 dev nodes. But with this container ID, the device only appears as a single picture when you look at it in devices and printers. This is particularly important for Windows 8 to really enable great Metro-style experience. We also want you to do this for all externally attached devices, particularly the ones that support different transport types. So if your device supports USB and Wi-Fi, we really depend on the container ID to know that it is the same device, because USB stack and Wi-Fi stacks are completely independent. Otherwise, they would appear twice. So we've learned how to select correct USB 3 chipsets and how to design firmware to take advantage of power management and also to appear correctly in Windows 8. Now let's move away from the hardware into the world of software, where devices, applications, and people all come together. So when a device is first connected to a PC, it gets enumerated by the USB stack. And so after some back and forth between the device and the USB stack and the PNP manager, Windows finds out what type of a device it's talking to. That's when the right device class driver gets loaded. And so device class drivers expose various public APIs that software developers can take advantage of and call and directly invoke certain functions on the device without ever needing to write kernel mode code, which is great because the device class driver will sit there and will do the translation between the software that runs in the user mode and the USB stack that runs in the kernel mode. In Windows 8, we offer 16 inbox class drivers to cover major scenarios. So for example, printer, we've got mice, keyboard, storage, and so on. It looks like, based on our Windows 7 telemetry data that many people don't like writing kernel mode software. And so 93% of all devices actually use inbox class drivers. In Windows 8, all devices that use inbox class drivers will be accessible directly from the Metro-style application without any extra work required from your side. USB Attached SCSI Protocol, otherwise the acronym is UASP, is a new inbox storage driver which is available in Windows 8, and it implements USB 3 transport type called Streams, which was introduced just to USB 3. The main benefit of it is that it allows for faster performance on concurrent transfers. So for example, it actually, some of the data that we've been seeing in our internal labs, that it can go up to 50% faster when you're doing concurrent transfers on UASP drives compared to bulk-only transport. And part of the reason is that with streams, you can parallelize the transfers versus with bulk-only transport, you cannot. We also believe that in the future, UASP drives will be a viable alternative for internal storage. So in Windows 8, we offer full USB boot support from internally attached USB devices as the means to boot the OS. All right, so what do you do when your device does not fall under the category of the 16 device class drivers? So if you have a unique heart rate monitor or a biometric device, do you need to write kernel mode code? Not necessarily. Windows offers a generic WinUSB driver. And so similarly to device class, you can actually use WinUSB.dll to invoke the different functions on the device. WinUSB.dll will talk to WinUSB.sys, and it will do the translation between the software and the actual the kernel mode code. In Windows 7, in order to take advantage of WinUSB, you had to create an init file that said, hey, I want to load WinUSB driver. However, in Windows 8, we made this really easy. And you can specify that you want to use WinUSB directly in the Microsoft OS container ID by supplying a WinUSB string. With this change, you will no longer need to create and certify an init file if you would like to use WinUSB-based devices. To summarize, Windows 8 offers 16 inbox class drivers, including a new USB storage driver, which utilizes USB 3 streams and offers 50% faster concurrent transfers. Plus, there's an option to use WinUSB, which is a lot easier now in Windows 8 for devices that don't fall under the major device class categories. Windows 8 eliminates the need to create any kernel mode, any kernel mode code, thus making driver development a breeze. So now, once you have completed building out your device, you've got your hardware, your firmware, and you've created a driver, or you know which driver you're going to use, you're going to start looking at testing it. And so this is where certification comes into play, as it enables you to validate the quality of your product. It is a final check to ensure that your implementation is per specification and that your device can recover safely from any unforeseen circumstances, that you're keeping the user safe and secure at all times with your devices. But before we dig deeper into the certification, it is important to understand the USB ecosystem and the drive behind the different certification programs available. So to date, we have 10 billion USB devices in the ecosystem. And this number continues to grow at 3 billion devices per year. If we look at the PC side, at the system side, there's about 1 billion PCs out there, all of which that have very unique characteristics, from form factors to motherboard layout to power, performance. For USB 3 in particular, there are 12 certified controllers, all of which offer different firmware versions as well. And so on top of that, we have BIOS, which plays a significant role in the USB 3 experience to make sure that the communication between the bus and the operating system all happen properly. So when you look at the size and the complexity of this USB ecosystem, compatibility becomes a huge challenge. And so for Windows 8, we're very much devoted to compatibility. But it is not something that you can scale to with a centralized testing approach. So this is why we invest heavily into tests and tools and procedures to make sure that together we can provide a compatible and reliable USB experience. So for the sake of time, I'm going to summarize the certification guidance into 4 major pillars. Millions of PCs that are shipping today are offering USB 2 and USB 3 solutions. We call those mixed port solutions. And so there are also millions of PCs with just offering USB 2 that users have in their homes. As such, there's no guarantee that your USB 3 device will be connected to a USB 3 controller and a USB 3 port. So it is very important to test them behind both USB 2 and USB 3 controllers. When a USB 3 device is connected to USB 2, because the specification is backwards compatible, it will function as a USB 2 device, so you will get the high-speed experience. If USB 3 device is connected to USB 3, that's great. You will get the full super speed experience. For Windows 8, we focused on making sure that we keep the API layer the same. And so all of the existing device drivers should continue to work without any changes necessary. However, I still strongly encourage you to go and test your drivers on Windows 8. You've all got access to Windows 8 builds now, and so if you do find that any of your custom drivers don't work, please let us know right away. Another thing to keep in mind is the configurations, how users plug in their devices. So many enthusiast users and developers use hubs, USB hubs. I personally only found out about USB hubs when I started on the USB team 2 years ago. But one of the key things, they make connecting and moving devices very, very easy. But apparently they're quite common. And so it is important to test your device behind a hub because the device might work very differently because you're adding another layer in the middle. In addition, cables get very tricky. Because the plugs are backwards compatible, you can use a USB 2 cable to connect USB 3 PC to your USB 3 device, in which case the device will work at USB 2 speeds. And so in many cases, users will just grab whatever cable they have on hand. So they might try it with USB 2. And so it is important for you as device manufacturers to make sure you test for these scenarios and that your device still works. And lastly, run all the certification tests that are available. They are free, and regardless of your certification needs, this is a great opportunity to make sure that your device is compatible with Windows, and that helps prevent any future support call costs. How many of you are familiar with the Windows Hardware Certification Kit? All right. So I'll talk a little bit about it then. So the Hardware Certification Kit gives access to quality tests at no cost. So it's available for everybody to download and to run. And at the end, you can actually submit your results for certification. And if once all the certification is confirmed, you can display a Windows logo on your hardware to indicate quality to customers. And this is something that customers actually refer to when they make decisions on which devices to buy. Another key benefit to Windows hardware certification is that it enables you to host your drivers on Windows Update. So if you do have a custom driver, you can upload it to Windows Update, and then it seamlessly gets installed when the user plugs in the device. This also makes driver updates very easy because you just upload it to Woo again, and then all of the drivers are propagated to the users. You also get telemetry data so you know your install base, and you can get some of the error results, and you can make your driver more robust. For USB 3, the Windows hardware certification requirements can be summarized into 5 major groups that we touched on during today's presentation. Each group contains a set of tests to validate that that functionality works correctly. So the first one is running USB IF tests. So as we talked about, you're not required to get full USB IF certification, but a part of the test need to pass. Also, there are selective suspend and function suspend requirements. Especially for internally attached devices, all of them are required to support selective suspend to allow better power consumption for the system as a whole. If you do have a multifunction device, then you need to implement Microsoft OS Container ID. And there's lots of information available about it because it's the feature that we had since Windows 7. If you're considering storage devices and you're looking into USB-attached SCSI protocol, there's a number of tests available in the latest Windows Hardware Certification Kit to help with development of UASP drives. And lastly, backwards compatibility is key. And so we want to make sure that your devices support both super speed and high speed descriptors and full speed descriptors correctly, so they can work behind different controllers. After over 10 years of experience working on USB 2, reviewing USB 3 specification, and testing lots and lots of USB devices, we have converted our knowledge into specific tests to provide to our customers. So regardless of your certification needs, I strongly encourage you to download Windows Hardware Certification Kit and run through those tests to ensure that your devices will be compatible with Windows 8. Now I'd like to call out some specific key takeaways of today's presentation. So if you're considering USB 3, then you should definitely take advantage of the power management and the performance benefits that it offers to customers. With Windows 8 available, you can test your hardware today and make sure that it works. If you do find any issues specific to our stack implementation, then you can do let us know. We'd love to hear your feedback, and we're open to your suggestions how to make a more robust experience. Run Windows Hardware Certification. I can't stress that enough. The kit has so many great resources, and you can actually use it later to obtain certification and display the logo to indicate quality. Participate in industry events. This is a great opportunity for all of us to get connected, to find out about different product plans and visions that you have in store to make sure that together as the ecosystem, we're building great experience for our customers. I would like to conclude my presentation with the following food for thought. USB 3 is up to 10 times faster than USB 2. It is also more power efficient. However, the most important aspect of USB 3 is that it's USB, and so users will expect all of their devices to just work. That means full, low, high, super speed, all of these devices need to work when connected to USB 3. We all need to work together to provide that reliable and compatible experience for our customers. And hopefully with today's presentation, you know where to start to achieve that goal. Here are some additional resources that are available for you. And so some sessions already, unfortunately, took place, but I do have them as a reference later on that you can watch on after the conference or in your hotel room. And then there's a number of documentation and articles that are also available. I'd like to stress out the USB Core blog. It's a great opportunity to find out directly from the engineering team that is working on USB about how to use some of the new features or what you need to do for debugging or diagnostics of your devices. And now I'd like to open the floor for questions. And if you don't have any questions, I have a great video to show. You want to see it? All right. Huh? Oh, no. Okay, you can hear. Great. Thank you very much for your time, and please fill out the review. Thank you.